Everyone, welcome to my YouTube channel, and the question for today is unique paths second. So the question is, a robot is located at the top left corner, that is exactly over here, that is for a start, and it can only move either down or right at any point in time. So either it can go this side or this side at one point. All right, so it's trying to reach at the end of bottom of the grid, that is the finish. Now also that the question is given that there are obstacles like this that are added, and that means that we cannot go from that path like this. If we are from here, we cannot go over here, we have to go down only. So like that. All right, so is obstacle is marked as 1, obstacle is marked as 1, and the empty space is marked as 0. All right, so this is a question that is given to us over here, and we have to return how many unique paths that would be there. All right, so yeah, I hope the question statement is clear to everyone. The question is not bit of a complex, but it's kind of a tricky one. All right, so given these situation, and we have to find the number of ways that is shown here. So one way is this, and other way is this, and now I think this can't be the way, and only these two ways are there. So yeah, I hope the example is clear here. Now let's see the example further. So they are not given any much example, that is a difficult one. All right, now let's see how we are going to solve this problem given to us over here. All right, so yeah, and this is the example that is like this point only, one is answer. Now let's see for the constraint that are given to us over here. The constraint given to us over here are that the m is equals to the length of obstacle, that is the length that is given here, and n is equals to this length. All right, and m and n can range from 1 to 100. All right, so it can't be a null matrix, and it should only be having obviously one cell, and so it will range up to 100. All right, so yeah, I hope that's clear. No, none of this is 0. All right, there would be a matrix, okay, where m is 1 and n is 1 as well. I hope that's clear, and it's not a strict square matrix. All right, it can be a rectangular matrix as well. That is that at any given point, the length would be greater than breadth, or the breadth would be greater than length. All right, I hope that's also clear, and it only contains the value 0 or 1. So where 0 signifies where basically the space, and 1 signifies an obstacle. All right, I hope the question is clear. So one very important corner case for us would be if the obstacle is at the starting point, and this is a very important test case, and it's depending upon the examiner as well. So they don't have mentioned that it can be placed or not. If nothing like this is if in the interview, if such question is presented to you, then it's a very good technique to ask the examiner about this test case. All right, so how he, it shows that how very well you understand the question and how you are going to approach it. All right, and also it gives a good impression to the examiner as well. So one such point, if it's not mentioned in this question, we will take it into consideration that this can be present here, and if it's present here, then we will obviously return 0. All right, I hope that's clear. This is a very important corner case to tackle, because every one of us can make this question, and it's a very easy one, simple dynamic programming question, but this test case makes it a unique one. So it's not mentioned over here, so how we'll tackle it. All right, I hope the approach here is clear. The question statement and as well as the constraints are clear up to here. Now let's see how we are going to solve this problem. All right, now let's see basically the approach. All right, so now let's see the approach for this question, how we are going to solve it. All right, so yeah, so because basically we are given that 0 stands for space and 1 stands for obstacle, that is we can move, and yeah, and also we can only go this direction or this direction. All right, now let's see with the help of simple example first. That suppose this is a matrix and this is the starting point, we will always mark it as 1 because there is one way to read this. All right, from to here. So yeah, I hope that's clear. And suppose if let's make it look little big, and suppose if there is an obstacle in this row. All right, basically what approach I'm following over here is a dynamic programming one. So if we fill these rows and this rows, then we can calculate all these results with the help of how many ways to read this and this point. All right, and since they are at in this row, because if we are going this direction, then only it will take only 1 because one in one unique way. So if we are at 1, so here is also 1, and here also 1. Alright, so yeah, like that. Alright, here also 1. Alright, now I hope the pretty much approach is little bit clear. Now let me just make it tell you some of the corner cases that might be useful. Alright, so these corner cases we should always keep in mind, and yeah, that's what I've taken over. Suppose here is a obstacle, alright, and this is a starting point and we have to reach here. Alright, no other obstacle. So alright, if we go from here, then here, then here, then here. Alright, now this point cannot be reached at any cost, because either we will go this side and this side. If there was a possibility that we get this at this side as well, then this might be reached. But since here is an obstacle, then we cannot reach here. So the given approach would be like that. If is there any obstacle that is 1 over here, then we will mark it as 0 only. But after that, if there is any value, because initially we are going to fill these and these rows, because to reach here it's one way, it's one way, and to reach here it's two way, that is one from here and one from here. Alright, so the dynamic programming approach we are going to follow, and since we can go in this and this direction, we will fill them first, and with these results we are going to fill the values at this point. Alright, so yeah, so if there is any obstacle while filling the initial array, that is the initial array, and if there is a new obstacle, we can fill in the same array, or we can take another deep array. Another deep array will cost us space, obviously, but yeah. So if there is another array and we see that if there is an obstacle, then every point after that would be always considered 0, because there is no way we can go from that point to the destination point. I hope this point is clear to everyone, and this is the only point that is to be mentioned, because if rest of this, if there is a point, we will just leave it, or state value as 0, and we have to reach this point. I hope the approach here is clear, and if someone of you might still facing any difficulty with this point, that is the most important one. So let me take it with the help of example. Alright, so suppose here is that, so we mark it as 1, it's 0 and it's 0, and here is 1 and here is 1. So now filling up, suppose there is also obstacle over here already. So 1 plus 1, the number, because we can reach this point from here and here. So number of ways to reach this point plus number of ways this point makes the number of ways to reach this point. Alright, so 1 plus 1, that is 2. Alright, now 2 plus 0, unique ways, 1 here, 1 here. Alright, now number of ways to reach this point will be 2 plus 0, that is 2, then 2 plus 0 is 2. Now 2 plus 1, 3 ways to reach this point, and 3 since it's 0, because it's obstruction. And now 2 plus 0, 2 ways only. The 2 unique ways would be 1 here, because we cannot move here. So 1 here, 1 is this unique way, and another 1 unique way is this. Alright, I hope that's clear. And yeah, alright, I hope the point of this also is clear, that if there is the obstruction of this, then every point after that will be marked as 0, because we cannot reach at that point. Alright, so yeah, and if you're still facing any difficulty, then I'll think that if we see the code, then it would be much clearer. Now let's see the code for this problem. So yeah, here is the code, and I have written few comments. So R and C for row and column, obviously, and this is the basic test case that I was talking about initially. Now because which is the starting point, we have taken it 1. Now we are filling the values, and we are seeing the previous value, that if a previous value is 0 and now this value is 1, then how will we going to mark it as value. Alright, I hope that's clear. And yeah, so how we'll mark it as 1 and 0, and yeah, and these are the values that we'll fill, and after that we'll just calculate the values. So if it's 0, that is it's an empty space, so we will calculate the value, that is the sum of the both the direction from where we can come, or else it's 1, that means that is an obstruction, so we will make it as 0, and at the end we'll return the last value that is calculated over here, and that would be our final answer. I hope the code is clear. Now let's submit it and see. As you can see, it's accepted. So if you are still facing any kind of difficulty in this code, you can feel free to reach me in the comment section. I will surely reply to every one of you. And if you like this video, please press the like button and share it among your friends, and subscribe to my YouTube channel. Thank you for watching. Bye bye.